Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're going to be finishing up the algebra section for Meet 3 and Meet 3 with it, so let's get into it. So just as a side note before we start, you will probably have to have watched the previous video, the first video for algebra in Meet 3, in order to understand what we're talking about today, which is absolute values and inequalities, because last video we learned about absolute value and inequality separately, but the material we're learning today combines both of them into the same question. So the first thing we need to talk about is absolute value inequality questions. They're basically just questions that combine both absolute value and inequalities. So an example of this would be, how many integers x satisfy the absolute value of x minus 17 is less than 4? So in order to solve these questions, we just need to use the concepts that we already know, and then use the inequality to figure out what the question is asking and what our answer is. So let me show you an example of how to solve this one. So your first step, like any absolute value question, is to break it up into two equations or inequalities. So I can break this up into x minus 17 is less than 4, and then x minus 17 is greater than negative 4. And I know that with equations, if this were an equal symbol, you'd have x minus 17 equals 4 and x minus 17 equals negative 4. But remember, when you have an inequality, if you have a negative number, if you're switching it to a negative number on the other side, and this is why I'm teaching this specifically, because this can be a little bit confusing. When you have absolute values and inequalities, when you break it up into your two equations, when you flip the absolute, or when you flip the number on the equal side, or on this side, to be negative, you have to make sure to flip the sign as well. So this becomes is greater than negative 4. And if you think about it, that makes sense, because if x minus 17 was negative 3, for example, then if you put this in this absolute value, that would become 3, and that satisfies the original equation. 3 is less than 4. So that's why you flip the sign. So now that we flip the sign, we need to solve both of these both of these inequalities, and then use it to figure out how many integers satisfy. So first we'll do the first one. So x minus 17 is less than 4, and so I need to get rid of this minus 17 on the left-hand side. So in order to get rid of it, I add 17 to both sides of the equation, to the inequality. So now I have this crossed out and just x on this side, and that will be less than 4 plus 17, which is 23. So x is less than 23. All right, so next I'm going to solve this one. So same thing, add 17 to both sides. And now what I do is I cancel these two out. I add negative 4 to 17, which gives me x is greater than, because I keep the greater than symbol, negative 4 plus 17, which is 13. So my conditions are that x is greater than 13, and x is less than 23. So now I need to figure out how many integers satisfy this, right? Because there are only a few values of x that are integers that actually will fit inside this absolute value and make it true. So those are the ones that are greater than 13 and less than 23. And remember, they can't be equal to 13 or 23 because we don't have a greater than or equal to sign, or less than or equal to sign here. So therefore, the values of x that fit it are 14, 15, 16, 17, 18, 19, 20, 21, and 22. And if we count that, because these are the ones in between 13 and 23, and remember, they're all integers, which means they have no decimals or fractions. If we count that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 integers x satisfy this. All right, so now I have a review question about inequality and absolute value questions. If you'd like to try it, I'll give you a few seconds to pause the video and then explain the answer. So the correct answer to this question was 6. 6 integer values of n satisfy the absolute value of 15 over n is greater than 4. So let's get into the question. So my first step is always to get rid of this absolute value, to break it up into two inequalities so I can solve them each individually. So first, what I need to do is write out my first equality, which is 15 over n is greater than 4. And that's just simple because all you have to do is remove the absolute value signs and it will stay true, assuming that this is a positive number. All right, the next inequality is a little bit more difficult. So the next inequality goes like this. 15 over n is less than -4. And remember, you turn this number negative, but because of that, you also have to flip this sign. All right, so now that we have our two inequalities, I'm going to go ahead and solve the first one. So the first inequality gets solved like this. You have 15 over n is greater than 4, and you want to get n all on its own. So this can be a little bit difficult because we've never really run into a problem where we have n in the denominator of a fraction. And the way you actually have to do this is you have to get n out of the denominator. It's not that you get rid of the 15, you have to get rid of n from that side because you always want n in the numerator. So what you have to do is you want to multiply both sides by n. You have to choose the right side to have n on. So let's multiply both sides of this by n. So 15 divided by n times n cancels this out and just leaves us with 15. And then that's going to be greater than 4 times n, which is 4n. All right, and now in order to get rid of this 4 multiplied by n, I have to divide both sides by 4. So if I divide both sides by 4, I get 3 3/4, because that's 15 over 4, is greater than n. All right, so this is my first inequality. Now let me do my second one. And this one is a little bit confusing, so stick with me here. So I still need to get rid of n in this denominator here. So I can do the same thing that I did over here where I multiply by n, but there's one thing that I have to do different. And that's that I have to flip the sign when I do this. It's not going to be 15 is less than -4n. And the reason why is because if you think about this, if you think about this equation or inequality right here, the only possible values that n could be to satisfy this are negative numbers, right? If say n was 3, it's not going to satisfy this inequality because 15 over 3 is 5, and 5 is a positive number. So 5 is therefore always going to be greater than -4. It's not less than -4. But the only numbers that n could be are negative numbers because when you divide by a negative number, that turns a positive number negative. And the only numbers that are less than -4 are also negative numbers. So therefore, in this inequality specifically, n has to be negative. So this is why instead of writing 15 is less than -4n, we're technically dividing by a negative number. Even though we don't know what n is, we know that it has to be negative, which is why we flip the sign again to get 15 is greater than -4n. All right, so now that we have that, 15 is greater than -4n, we have to divide both sides by -4 to get rid of this -4 multiplied by n. So if I do that, and yes, we have to flip the sign again, then we get -3 3/4 is less than n, because the -4's cancel out. All right, so now we have two inequalities. 3 3/4 is greater than n, and -3 3/4 is less than n. And if we just write this out as one inequality, we have -3 3/4 is less than n, which is also less than 3 3/4. Because remember, 3 3/4 is greater than n, so n is less than 3 3/4. So now we have this one inequality, and we have to figure out how many integers satisfy it. So an integer is just a number that is doesn't have any fractions or decimals, right? So we have -3 then, because that's in between these two, -2, -1, 0, 1, 2, and 3. So that gives us a total of 7. But you'll notice that I have the answer here as 6. And this is where you have to be really careful. And you need to make sure you check your work to make sure all of these values actually work. If you plugged all of these values back into this original equation, which is what you should do, because otherwise you might get an extraneous solution, which means a solution that you work out mathematically, but when you plug it back in, it doesn't work. We actually have one here. If you plugged these all back into this original inequality and tested if they worked, you'll notice that these three work, but 0 does not, because you can't divide by 0. If n were 0, you'd be doing 15 divided by 0 is greater than 4. And if you divide by 0, that gives you an undefined number. So you're not allowed to divide by 0. So therefore, 0 is not an integer value that satisfies this equation. So now you only have 6 total, so your answer is 6. All right, and finally, we're going to talk about inequalities with multiple variables. So some special inequality questions are going to have more than one variable in them. So here's an example of this. So this says, for what value of c is the solution to 3 times x plus 2 minus 4 less than 5 plus 2c, that x is less than negative 1? So questions like these can look a little bit daunting at first, but I promise you they're not as difficult as you'd think. And the reason why is because they're asking you basically to turn this inequality here into this inequality by figuring out a value of c that works. So let me show you how to do these. Essentially, what you have to do is you have to simplify both sides so you end up with this. You're trying to turn this mess here into this, where x is less than negative 1. And the only way you can do that is you put in an integer value for c that actually works. So let me show you how to simplify this. So first, we're going to get rid of this parentheses. You always want to simplify your equation as much as possible, or your inequality as much as possible when you're doing these types of questions. So you have 3 times x plus 2, and if you use the distributive property, you can multiply 3 by x plus 3 times 2. So that gives you 3x plus 6 minus 4 is less than 5 plus 2c. All right, so you can simplify this a bit more, where you can do 3x plus 2 is less than 5 plus 2c, because the plus 6 and negative 4 combine to get 2. So 3x plus 2 is less than 5 plus 2c. All right, so now you can still simplify it a bit more, but we're not going to do that quite yet. First, I want to explain how to get from here to here. So in this inequality, what you'll notice is that x is on the left-hand side, and that your constants are on the right-hand side. So therefore, if you're going to simplify this, in order to get to this, you want to isolate the variable x. You want to get it all on the left-hand side, and we can deal with division later. But first, we want to make sure that 3x is the only thing on the left-hand side. So therefore, I need to get rid of this plus 2. So I have to subtract 2 from both sides to get rid of it, because they do the opposite operation of the same number. And that gives me 3x is less than 5 minus 2, which is 3, plus 2c. All right, so I have 3x is less than 3 plus 2c. So this is where it gets a little bit complicated, because what you have to do is you still need to simplify this down to just x, but you need to divide both sides by 3. But the issue is that this is 2, right? It's not easily divisible by 3, so you are going to have to work with fractions here. So you want to get this only to x. So you have x is less than some number, and then you can figure out what c is. So yes, we do have to divide both sides by 3. And when you divide by 3, you have to make sure you divide everything by 3. So 3x over 3 is just x, which is less than 3 plus 2c over 3. And when you divide this, you get 1 plus 2/3 c, because you have to divide everything on both sides by 3. So you get 1 plus 2/3 c. So now you have x is less than 1 plus 2/3 c. So if you think about it, 1 plus 2/3 c has to equal negative 1, because that will turn this into x is less than negative 1. So if I write that out, now I have an equation where I can solve for c. 1 plus 2/3 of c equals negative 1. So now if I solve for c, I want to get c all on its own, which is on the left-hand side. I subtract 1 from both sides to get rid of this positive 1 here. And that gives me 2/3 c equals negative 2. And in order to get rid of this 2/3, I have to multiply by its reciprocal, which means the fraction flipped upside down. Because if you think about it, you're dividing by 3 and multiplying it by 2. So therefore, you need to divide by 2 and multiply it by 3, which is multiplying by 3/2, or 2/3 reciprocal. So if I multiply both sides by 3 over 2, these two cancel out, and that gives me c equals, and then negative 2 times 3/2 is negative 3. So therefore, c has to equal negative 3. And if you substituted that back into this original equality, you would find that negative 3 actually does turn this into x is less than negative 1. All right, so now I have a review question about inequalities with multiple variables. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was B is 16. So with these questions, you always want to get this inequality to turn into this one. And the first thing you always have to do is simplify this inequality as much as possible before you figure out a value of b that works, because that will make it a lot easier in order to get a value of b that does work. So first, we're going to simplify this inequality. So I need to get rid of all my parentheses, because that's always your first step in simplification. So what I do is I multiply 16 by x and subtract 16 times 1, using the distributive property to get rid of this parentheses here. So we're going to do that one first. 16 times x is 16x minus 16 times 1, which is 16. All right, so this simplifies to 16x minus 16. Now let's simplify this parentheses. So same concept, I used the distributive property, but I have to make sure that I multiply by -4, because just because you're subtracting 4, it actually means that you're subtracting this entire section. So I need to multiply that by -4 instead of just 4. So -4 times x is -4x, and -4 times -2 is 8. So plus 8, because it's a positive 8 that we get. And that's all less than b. All right, so now we have 16x minus 16 minus 4x plus 8 is less than b. Now we can combine like terms, which means our x's and our constant, in order to simplify it a bit more. So 16x minus 4x is 12x. -16 and positive 8 combine to get us -8. Oops, I wrote a plus sign here. Minus 8. So now we have 12x minus 8 is less than b. And we want to turn it into x is less than 2. So now what we're going to do is we're actually going to move this positive 8, or this -8, over to the other side, because we want to get x all on its own on the left-hand side, like it is in this inequality, because that way we can figure out an equation for b that actually works to find the value of x. So if we get rid of this -8 by adding 8 to both sides, or doing the opposite operation of the same number, we get -12x minus 8 plus 8, which cancel out, is less than b plus 8. So 12x is less than b plus 8. All right, cool. So now in this inequality, we have x is less than 2. So we have 12x here, so we need to get it down to just regular x. And in order to do that, we need to divide by 16. So if we divide by 12. So if we divide by 12, we get this divided by 12 and this divided by 12, which gives us x is less than b over 12 plus 8 over 12, which is also 2/3. So x is less than b over 12 plus 2/3. And now that we have it in this form, since x is less than b over 12 plus 2/3 and x is less than 2, then that means b over 12 plus 2/3 has to equal 2. So if we write out that equation, b over 12 plus 2/3 equals 2, then we can solve for b. So I have b over 12, and if we want to get rid of this 2/3 here, because we want to get b on its own, then we subtract 2/3 from both sides. And you have to be ready to work with fractions here, because they're going to show up in most of these questions. So if you subtract 2/3 from both sides, you get b over 12 plus 2/3 minus 2/3 equals 2 minus 2/3. Or b over 12 equals 1 and 1/3. And so now what I'm going to do is I'm going to write this out as what's called an improper fraction, because it's kind of difficult to figure out what the value of b is going to be if I don't write this as an improper fraction. And actually there is another way that I'll show you in a sec, but this is the way that I prefer. So if I write this as an improper fraction, which means it's only a fraction and it's not a mixed number like this, this gives us b over 12 equals, and then we have 4 over 3. All right, so now I have b over 12 equals 4 over 3. So in order to get b over 12 to be equal to 4 over 3, I need to figure out what number divided by 12 gets 4/3. And if I figure that out, I have to multiply by a form of 1. And this is how you simplify fractions and make sure they have the same denominator, because I wanted to have the same denominator so I know what b is equal to. So if I multiply by 1, which is 4 over 4, then this gives me 16 over 12 equals b over 12. So therefore, b has to be equal to 16. So that's the method I prefer. And that might have been really confusing, especially if you haven't really worked with fractions that much. So I'll just show you a second method, which is a little more algebraic in order to solve it. So you could also just multiply both sides by 12. I don't prefer to do that because I have to multiply by fractions, where here I just changed the denominator and numerator by the same amount. But anyway, if I multiply both sides by 12, from b over 12 equals 1 1/3, and when you multiply 12 by 1 1/3, because you're getting rid of this divided by 12 here by multiplying by 12, you'll have 12 times 1 1/3 equals b, and 12 times 1 1/3 is 16. So 16 is equal to b. All right, just to quickly review what we've learned this lesson. So first we started with going over how to solve absolute value inequality questions, which is basically when you have both of them in a question. So what you do is you use your normal absolute value techniques and break it up into two inequalities. But when you break it up into your two inequalities, when you flip the number on this side to be negative, you also have to make sure to flip the sign. So this less than would become a greater than if you turn it into x minus 17 is greater than -4. And then you solve the inequalities like normal, and then you find your integer values that satisfy it, that's in between the values possible. So then we did a review question about absolute value, where we found that the absolute value of 15 over n is greater than 4, or the values of n that satisfy that, their integers, is 6 total. Then we talked about inequalities with multiple variables, which are inequality questions that have a variable in them, and then a second variable that you need to find the value of to satisfy a second inequality with the original variable. So what I mean is we had 3 times x plus 2 minus 4 is less than 5 plus 2c, which we needed to turn into x is less than -1 for some value of c. And the way you do this is you simplify the mess, which I'm calling this inequality, as much as possible to get it as close as possible to this inequality. And then based off that, you create an equation in order to find the value of the other variable. Then we did a review question for this, where we found that the value of b for the solution to this inequality system was 16. So that's all I have for today's video. I know it's probably a really difficult one, and algebra is definitely the most difficult category for me to explain. But that is the end of this video, and I hope it is helpful. And that's also the end of Meet 3. See you next time.